So the only way you can know a tilt of a vertical is when you reference it to another vertical.
Yes, there you go.
Hello, I'm back again to take a look at Blue Marble Science's debate with Bev Try Thinking. Bev asserts that all horizontal planes are parallel to one another, while Blue says that's not true for a globe Earth. So in this presentation, I'm going to look at what happens when we cut two vertical lines with a straight line between two observers for both flat and globe Earth. Here I've got two observers and they're both currently at 0 feet. With these controls, I can alter their heights and their distances from each other. One thing we all should have learned in school is what happens when you cut two parallel lines with a transversal. And hopefully we all should have discovered that these two internal angles are supplementary, which is just another way of saying that they always add up to 180 degrees. So what about Bev's claim then, about all horizontals being parallel with one another? Let's test that by creating some perpendicular lines to each vertical, and then we can measure some angles. And we can see that this blue line is perpendicular to vertical 1, while this red line is perpendicular to vertical 2. Well, we'd expect that this blue line is at right angles to its vertical, and the same goes for this red line. And you could say that the blue line is horizontal at vertical number 1, and the red line is horizontal at vertical number 2. But are these lines horizontal at both verticals? This tells me that they are. And now we can say for sure that this blue line is parallel with this red line, and this vertical number 1 is parallel with vertical number 2. So it's all looking good for Bev at this point. That is, if the Earth is a flat plane. What I'll do now is switch to a globe with a radius of 3959 miles, keeping observer heights and distances the same. Brace yourself for this massive change. The first thing to notice is that the co-interior angles total to more than 180 degrees. So that means the verticals are not parallel with each other. So what gives? Checking this box shows the sector for the two positions. And as you can see, each position follows a straight line path or gravity direction to the center of the Earth. If horizontal is defined as something perpendicular to vertical, then we can carry out the same test as we did before. So I'd expect this to be 90 and this to be 90. But will the red line that's horizontal at vertical 2 be also horizontal at vertical 1? The answer is no. Same for the blue line. It's kind of obvious that if the verticals are not parallel, then neither are these horizontals. Now it's looking just as good for blue as it does Bev, and it seems to me that this boils down to the shape of the Earth.
In 2018, those two guys got together at the Hagerstown, Maryland airport and High Rock Lookout, about 11 miles apart, and measured reciprocal zenith angles. Larry was at the airport over there, that's Larry's theodolite, and Jesse was up on top of High Rock Lookout, where that red arrow is. Those two guys measured the two zenith angles, and here are the actual measurements. That is with no refraction correction. If you include refraction, that increases from 7 minutes 53.2 seconds to about 9 minutes and 40 seconds.
I've roughly copied Larry and Jesse's heights, and this arc distance is exactly 11 miles. Here, the sum of the co-interior angles comes out to 180 degrees 9.5 minutes, and that's not that far away from their result. When you consider all the real-world data Blue brought to the debate, while Bev was still stuck on which way up and down was on the surface of a globe Earth,
Can you stand on the side of a ball?
you have to come to the conclusion that all verticals are not parallel, and by extension, all horizontals are not parallel either.
I can stand on the side of a real big one, yeah.
Can you?
I'm doing it right now.
Sorry. Can we put the camera on? Let's have a look at that.
Standing on the earth, Bev. It's a really big ball.
You're standing up though, aren't you?
Yeah.
You're not on the side of a ball, are you?
Yeah. Depending on what you want to call the side, but...
You imagine you're standing on the side of a ball.
Any point you want to pick, you can call the top, the side, the bottom, anything you want to call it. It's all the same. My vertical is straight down to the center of the earth.
With the tilt.
Only with respect to another vertical.
That's going to be the end of this video. I'll leave a link for this presentation in the description for those of you that want to have a play. Remember to like and subscribe. Thanks very much for watching, and I'll catch you later.